All right, we are going. This is the breakout session for the Biosimulations workshop. And Eran is starting us off.
All right, yeah, I'll try to go quick because I think we have a few things to hit on today.
Yep.
So, okay, this is, let's see what I do this. No, not start video. We're gonna share. Can everyone hear me online?
I can hear you.
Okay. Let's get some of this. Now we go to that. Let's go. Here we go. So I'll look. I'm going to try to hit a few points just to introduce you, and then we'll go to one of the ideas I had about SEDML 2.0. There's a connection there to biosimulators that we can also talk about.
Yep.
Okay. So I've been working on a composition protocol.
Can you introduce this? What are we looking at?
I want to show you. So actually, let me maybe let's start off with with this, and talking about vivarium, but this has been abstracted away. So I'm just showing you this slide because it's what I have, but it's we'll be talking about more general purpose. There's two basic elements to this paradigm. You have processes and stores. Processes are like your function. You have ports that are the inputs and outputs. You run whatever model or map you want in here, and then the update comes out. Another one with the ports or two ports. Stores can hold any data type, integers, floats, arrays, more complex things, strings, entire images you put in here, and they're typed. So you can what type it is. You also add units, so it can be like float, but some concentration. Okay, wire.
Quick question. So like, can things come in as a port into a port and then themselves change, like basically passing something as a reference in computer speak?
You can like a string through the port.
No, like a model object. Like I'm passing it a model object and it updates and it changes, and so it's not an official output, but it has changed because it was run through the thing.
So let's say instead of highlights, this is a model.
Right.
Object, an SED-ML type that's run through this port and it's being over here. You can operate on it. It's not going to change the original one over here because that's protected. So you can like copy it, modify it, but then if you want to change it, then you have to pass an update to change the external model.
Okay.
So you could, for example, read in the model, operate in it, and pass it back out of port to.
So like, at least Roadrunner has the idea of like, there's a model object that is the model state. And so if I say, go to steady state, then the model changes and its internal variables are now at steady state, and I can query it about like, what's S1 now, or whatever. So it is a ball of states and rules. And then that object can be moved around and you can ask different things of it. You can ask to simulate it, you can ask to reset it in some ways, but not in others.
This is entirely flexible, and
okay.
So if you can specify this in data report,
yeah,
you can do that. You can separate out the state, just pass the state out
if you need to.
or you can the whole thing can come out, and anything can go across these ports.
But I think what you're referring to, Lucian, is whether you're actually getting an instance that's not externally modifiable.
Or it is externally modified. Yeah. Like if you basically in computer science, it would be a function that takes something as a reference, like a list, a Python list or something. You pass it in and then you can change it. And now if anyone had a pointer to it, that pointer is now to the changed version. It isn't to the original.
Yeah, I try to protect things from like changing in place. Because something else might be using it at the same time, and
So there's parallelization issues with
there's
that, but yeah,
parallelization. So updates should go across the wire. You view
but
it.
they don't have to, or is that a
Here's-
design
this
principle,
is-
or is that is a design principle that you cannot update them something states, or is?
Because most simulators have a vector
Mhm.
in vector states.
Yes.
This is for performance reasons.
Yeah, so it's like shared. I mean, you can turn it off and do it in place. I think it's gonna be very hard sometimes to understand what's changing what. But if it's for optimization, you can turn off that feature, not protect it.
Okay,
In place. Another challenge is you might want to distribute this, so these two processes can be on the same CPU. And they have like shared memory, but you might also want to put one of these processes on a different computer. And then it doesn't have shared memory, so you can't do what you just described.
Right,
Then you actually need to pass it out for a port. So just to keep these things kind of.
But
And-
generally, if you're modeling glycolysis, you don't want to distribute it.
So
You want a thing called glycolysis
Yeah.
with its own ports,
yeah,
but something else can come in, but it's independently simulatable. So it's simulated for 1 millisecond and then let things come in and ask it what's happened.
so we can put entire composites on a single CPU. It does save some work because if these are on separate computers, let's say metabolism and signaling are on separate computers, then you actually have to serialize the
Yeah.
state, deserialize it, read it, modify it, serialize it, pass it
I
across the
think you
wire.
have to be careful at where you granularize,
Mhm.
because otherwise you'll get terrible performance issues.
If you go all the way during it, yes.
So you might have I can see the idea of having, chunks.
Yep.
That represent distinct things that should be themselves distinct.
And
Yeah,
you can do that freely with it and just say where you want to make the cut.
Yeah.
That thing under the cut all goes on the same CPU, shared memory.
Can you use existing simulators to handle those chunks?
A whole chunk, one simulator per chunk.
So you have modeling glycolysis.
Yeah,
Can you have one simulator handling that, an existing simulator?
yeah,
So you don't have to write your own.
absolutely, yes.
But you don't want to get it right.
Well, we're
We're gonna use but.
Sorry, but yeah.
So this is.
Well, it's important because if the architecture has problems with performance, then
Yeah.
nobody's gonna use it.
So I'm gonna actually focus on just the spec, because you can load in, one of, so here we're like, let's say we have, this is a simulation here. So we have 3 processes, running, you could, so here, for example, Herbert, we could make a cut right over here.
Yeah.
And this gets shipped off onto one computer.
Okay.
And so these have shared memory.
Yeah.
But then this is on a separate computer, and so any kind of communication with this process, you need to do message passing. And that you can do freely. But so this is 2 processes. You might want to have one process if it's just libd roadrunner, reading a bunch of states, writing a bunch of states, and then something else. So
Yeah.
that you can do freely. What I want to show is more of the spec. So this is just the data.
Affecting, so.
Yeah, this is just the, this is just data, you pass it into Vivarium, it'll make an instance and run it. What I wanted,
Can you clarify one thing for me? So how are exceptions handled? I see data flow, but I'm not sure I understand how exceptions.
like, if they're there,
Yeah, there's never.
then thing stops.
But how do I mean, you've got this complex, sort of workflow that's constructed.
Yeah.
How do I debug it? How do I figure out where, because I'd like to know where it came from and, what caused it, that kind of thing.
Yeah, so if there's an exception, it'll tell you at what store the exception. It'll tell you failed to, this update that you passed failed to be applied over here. Or you might have an exception from within a single process.
Right. Will I get some sort of is there enough logging so I can get in the history? Because the
Yeah.
problem may not have been in that process.
Yeah.
It may have been
I think
many steps before that.
so. I think this is engineering and it's important. And we have some of that available in Vivarium. I don't think that, I don't want to necessarily let my variance, just how do we
Okay,
specify?
no, I didn't know if there was,
Yeah.
you know, something.
We've done some logging, currently it still actually requires a lot of just being in the debugger, but that's something we want to improve.
Yeah, but I mean, we could always add some logging, like this is the perfect use case for something like Kafka or something. So there's one, one central place for all of the exceptions or logging to go. Right now, we don't actually have the distributed implementation. What we have is we can distribute across CPUs, but we don't yet have distributing across computers yet. I mean, it's going to be the same in principle. It's going to use the same protocol, but once we're distributing across computers, then we're going to have to distribute things like logging and everything else.
Yeah.
So
You're using for that, just socket or something.
For the distribution, we're using multi-processing.
Oh, yeah.
Is getting some speed up. Okay, so that this is, you can do so you can treat entire, this is actually related to her discussion. You can put an entire like composite process. So this top one acts as though it's a single process, but inside of it, it has. Okay, I want to go to this thing. I wrote this up last night. What if SEDML 2.0, you could do it like this? So here you have parameter estimation estimator. We might even say something like address, and we give it some URI, like where are you going to find this parameter estimator? I'm gonna comment that now. This has ports. So for a parameter estimator is a type which has these ports, input data. Right now it's any, but we could give it a subtype. A model, let's say this is an SEDML parameters, we could say this is an array. And then you need wires. So you go from the port to the to a store. And I connect all these up. And also here, this is a type. So I could add like the type. It's a step process. That's a detail you don't need to worry about, which have it depends on schema. This one doesn't depend on anything. The simulator over here, you can see the ports that are defined for it. They all need to be connected.
Oh, yeah, so this is where that simulator can be some existing.
Yeah,
simulator.
you can actually say like I can give it an address and point it to a simulator and a version number, for example. This one depends on parameter estimator. Here we have an analysis. It has single port results, but probably we want additional ports. It has a wire that the results port connects to this, and this one depends on the simulator. Okay, so this is the results. So here, the way that this would work is the parameter estimate, and you can also see that you can see the workflow as a result. Look, I just put in that spec. So the parameter estimator runs first, then the simulator, and then the analysis. The way that would work is the observed data and the model would be read in. These ones wouldn't be running yet. Simulator analysis wouldn't be running. It would write out the parameters as a result out. And as soon as this is done, it would trigger this one to run. It's just like a workflow. Reads in the model, reads in the parameters, reads in the total time that you passed in, runs for some time, writes out the results. Once that's done, results right into analysis.
When you say analysis, what do you mean? What kind of analysis?
You tell me.
So I'm just thinking about the relationship to SEDML. I mean, should this be its own distinct formula? Basically, you're tying simulators together. You're running a complete simulation. You're not doing an experiment. SEDML.
Called it the composition interface protocol.
Okay.
And we left open how much of this should be supported by SEDML, or will it be parallel or whatever, it's
Because you're overloading. You're overloading what SEDML.
correct. So
we should avoid that.
So were we your process, you have the composition interface protocol as one entity, then you have a process interface definition and third one, a composition exchange format. And,
So this is roughly the exchange format.
right, that's what you were showing here, and then there's on the implementation side, you have deployments and implementations that, you know, you can Dockerize, you can do Jupyter notebooks, you can do all sorts of stuff, but from a standards perspective, I have here the sort of higher level slides.
You want to share that? You want?
Yeah.
Actually, so this isn't just a simulation. This is doing some parameter estimation.
Well, but you could do
Yeah.
many things.
Well,
In-
then
in-
you're moving into the realm of SEDML.
This is.
In this particular thing, you did a parameter
Right.
estimation, you parameterized the model based on that, and then you did a simulation. And then your analysis is just you plot the.
So this is how we're thinking about
I mean, I could see a parameter, I mean, we have
No,
parameters.
I know that, but he has the ideas of ports, multiple simulators. It is a different thing where you're putting together multiple models to construct a bigger model. SEDML then is going to
Okay,
find
so-
the experiments you do on that bigger model.
So this is.
So he's mixing in building a model and doing experiments on the model in one script.
Right, maybe we could do stronger typing that says a simulator is, you know, we could break it down more coarse grain and say, this is the schema.
I mean, there is, the model itself,
I'm on the fence, I'm not
Yeah.
saying either way, I
Yeah.
don't know. Could we overload SEDML with composing models as well?
Well, yeah, but this is something that will kind of come to discuss in the site.
I mean, it's not in V2,
And
there's nothing about composing in V2.
okay, so technically, you can compose models in level 1 if you do XML changes, right? You can add XML, you can delete XML. And so this is actually even less than that. This is just parameterizing the model. This is running a parameter estimation
No,
task.
I know. Yeah. I just-
And then it's, well, I mean, the model itself, as in the structure of the model, is not ever changing. You're just parameterizing it and running a simulation. Which that's been.
To me,
set
there
up
was a
forever,
distinction,
yeah.
the model, we did the model,
Yeah,
very clear distinction. This,
so
putting both together, the model, and I didn't like this thing in SEDML1 moving, that was part of the model as far as I was concerned.
yeah,
If you're doing, you know, some genetic, running a developmental model, you will be removing and adding things if you come on and off.
yeah.
It was a bit weird, I thought. But if that's part of your simulation experiment, or maybe you're running a genetic algorithm, you could imagine adding, you know, that's not part of the
So
model.
that's what you see
Oh,
the way
yeah.
in C. You know,
C.
that's. So you have processes and states, you know, the processes need to have ports that you show in more detail. And you can declaratively assemble a composite and what the wires and the links are in between them. And then you orchestrate using some orchestrator how to use this to run an experiment.
No, the orchestrator is building a model, and running a model, the experiment, then they said, what are you gonna do with that model as you run it?
Great.
How long are you gonna run it
No,
for?
no, so.
Are you gonna apply-
The orchestrator is just the endpoint of running 1 or 2 or 10 simulators that updates each other.
But hold on, Roadrunner is an orchestrator then. Internally, it orchestrates all the states.
There's multiple orchestrators,
So,
obviously.
but I wouldn't claim that's a SEDML function. I'm trying to separate, you know, areas of concern, like who does what.
Yeah.
To keep things
Hmm.
simple, so we don't overload one part to do multiple things. I remember yesterday you were complaining about the repeated tasks.
Right.
To do 8 things.
And that's why we broke it down.
I think, personally, I think there's room for 2 stuff. That's what I'm saying.
Yeah,
We're-
well, we can.
One to orchestrate much bigger models, one to put big models together, tying simulators together, which basically as the Baron does, And then a separate sign says, what are we gonna do with this now that we've built it?
Each of these is a different composition specification.
You don't build a static model that you then use. This is, I think, where the lines are being blurred a little bit, because you're assembling a composite in order to run various elements that are linked in a specific way, but that's built per use.
Yeah, that's okay, it's fine, but you can have a standard that describes how the things.
So you have this, you need a standard to describe how they relate to each other, the different
Yeah,
components of the
fine, you have
composite.
four
And then you need a
sets of-
standard to describe how they interact with each other as you are using them to produce your end results. Which has been the purview of SEDML, right?
okay, here's another question. Let's say we built a big model, right? I now want to do an experiment, but I'm gonna run it 1,000 times, create an ensemble of data. Who describes that experiment? That's the same standard.
The last part.
Not necessarily the same standard. Here, can I share my screen?
I mean, where does SEDML fit in then?
Okay,
So SEDML is a composition and a experiment description language. Is that what you want to do then?
I think you can get both.
That's the.
So
that's the
here,
Question that
So
we
you
want
need
to
to
bring up.
control, but should it go into one standard?
That's why we wanted to discuss in like into SEDML.
Worry
How much of this goes into SEDML?
I just worry that some years' time, we were thinking, why did you do that? Why did you mix everything together?
okay, so we can go like this, experiment. This is now a simulation experiment specific schema. And I can share this with you, and you can reuse this one. In which case you can load in whatever model. This is just a schema, it's not an instance, right? You could load in a different model. You can load in a different, it's gonna be, this is actually a SEDML simulation experiment, because this port requires an SEDML model.
So, okay, in that case, should we just expand this to V2?
I think so.
That's what we were proposing, but we don't know where to put the boundary lines.
I think maybe we've spent enough time
Yeah,
on this
probably,
right now.
probably we did, but this is
So this is an extremely important conversation.
It's very,
Where future will go. right?
where
yeah.
SEDML will go, right?
Yeah. Now, this is all declarative as well, by the looks of it.
it's entirely declarative, but you can build it procedurally. So
Okay.
I've shown different notebooks that you add a parameter estimator, you wire it in a procedural way. In the end, the output of that is this. So you can always go, you build up an object, at the end you say to JSON, and it spits this out.
I mean, how simple would it be to do a parameter scan? To set up steady state. Say what you're looking at, changing a parameter and observing steady state.
Put that together.
It's not there currently though. If you put and
Yeah.
enhance this.
Yeah,
So obviously you can use this with single models. It
Yeah,
doesn't
then, yeah,
have to
right.
be-
No, yeah, you can use it as a single model.
You can use it with a single model.
Yes,
I mean, and I've been using it for composite
If
models, but
that's probably where you start.
single,
Convince the rest of the SEDML community.
this should
They're
be a
all single
single,
model people, right?
yeah, this should be an SEDML ML
And the
simulator.
ports is an extra thing you add on, because that's gonna be a fairly specialized activity.
Yeah,
Yeah, but. So the idea is that. What we do is one model, which is the first step of bringing the extra thing into SEDML, should be from the get-go compatible with. What we will need when we expand to composite models.
Yeah, I think you should how would a single model work on this? To do all the,
yeah,
when we have a whole lot of use cases for SEDML V2. You have to ask, how can we implement all those use cases into this? Just for a single model.
Well, are you familiar with that list? You know where that is?
Well, with a single model, you have multiple instances of a single model that update each other or running
No,
parallel or
it's
whatever.
it's classic systems rather than one model. Both models today are, right? They're one of the few who's thinking about composite models.
Alright, we
But
could, so we could,
there's no multiple there, you know.
this is a single simulator.
It's a single simulator.
So when you need to go through those use cases, check that you can.
Yeah.
You will have to enhance this probably.
Yeah.
I don't care what V2 is in the end, so long as it works for us. It,
And this is,
that's
this,
my only requirement. I mean, you could do this in Chinese if you wanted to, as long as it works, I'm
no,
happy.
we want English. Yeah,
You know what I mean, right?
yes,
I don't
yes,
mind.
I can
Yeah.
prototype.
I don't mind how you do it, but as
Absolutely.
long as it satisfies the user community.
Eran, do you know where that list is? Can you find it? Like, we have a list of things we would like SEDML level 2 to accomplish.
I've seen it before, yeah.
Yeah, it's okay.
Okay, let's move
That
on
was a good
to biosimulations.
Okay.
Okay, thanks, everyone.
Yeah.
Happy to talk. I mean, clearly there needs to be more discussion, but I think this was.
Well, this is very, very important, because SEDML is the blocking thing of the model.
Yeah.
For widespread reuse for them. Right,
I agree,
so-
I agree.
composite fun, but. Oh, significant concern to you. But the rest, for me, yeah, great, can we do the single model?
Yeah, I mean, getting the single models right, if we have the right cross interface, that helps me too, because I can reuse it. All right, do you want to demo this?
Okay, yeah. So. Let me. Guess I need to share that, right?
Yes.
Okay, so just to, most of you are familiar with this, but as a sort of reminder, there's two different GitHub organizations, Biosimulators, one, and Biosimulations, the other one. Each of them have multiple repositories, and they have Biosimulations needs biosimulators. Biosimulators does not need the biosimulators. So, and they also have different front ends that they're shared together. And, Lal and Jonathan had presented this at previous meetings already, where you can move between different components, but even though you see here like 5 different things, everything except biosimulators is part of biosimulations, right? So only the leftmost tool that also has a different color bar is a separate entity, and that's Biosimulate Forms, which is the registry of containerized tools that can execute omics archives in the most simple summary. All of them are required to be able to do -I input omics, -O output folder. And everything is specified with models, SEDML, metadata, whatever in the omics. And this is the list on the Biosimulators page that are all the simulators that have been to some degree included. And the curation level has different levels of stars, depends on how far that particular simulator has been integrated to implement the capabilities. And 5 stars means that it does have this full execution capabilities. Now, you,
So none of those are like judgments of the tool. They are just how well integrated they are
Correct.
into
Yeah.
run by.
and for each of them, the registry maintains the specifications of what they can do. So on the filtering, you can say, well, show me all that, SBML, that can handle SBML as a language. And maybe also BNGL, so you can filter,
Oh, that's both though. That's not an and, right? Apparently.
yeah, so it's, I think that's an or, maybe.
Yeah,
not an and.
I think those clicks are ands. Sorry.
And, what simulation formats they can handle, what archive formats. So a number of these things, and if you actually want to see what the integrated version of, let's say, Tellurium supposedly supports, in the overview, you have links with license, duration status, whatnot. You have the algorithms that it's JSON spec saying it supports how many versions have been deposited and containerized in Biosimulators, which is not what the latest version of Tellurium is out there. It's-
Yeah.
And
I keep trying to update that. I almost got it last night and I ran into some other problem. Like, oh, anyway.
Right. And the full specification JSON with all the information about authors. And other things. Okay, so that's the registry of simulators. What can you do with that? All the rest is implemented in biosimulations, where I want to first start by pointing out this part, docs.biosimulation.org. Jonathan did a great job of documenting very extensively the concepts, the implementation of almost everything client side. Server side, the documentation is not quite as complete, but most others don't care about that much. And the API, which is a standard REST API, and the things that I implemented in the Biosimulations web online portal use the REST API, but you can use this REST API from anywhere. And Joe, who will present later, just use the REST API to just pull in all the data to have a local repository of the simulation results over there, on which you can prototype a different portal and viewer. But you can use the API to do anything. Now, what can you actually do? So one thing that's unique, and I'm not going to start on the main page, is this. In order to execute an omics archive, you need to actually make one first. And there's a few tools that can make the full screen.
It's closed. Maybe just zoom in some.
Yeah.
Maybe just
Not-
zoom.
Yeah, I need time. The stupid Zoom is covering my.
And you.
Oh, the zoom controls are, yeah.
The little.
Can you just do Shift Control Plus?
Right, in that area.
Shift Control Plus should work.
Oh, yeah.
There we go. Okay,
Is this better?
that's good,
Yeah.
yes.
Thanks.
Well, I think on the projector is not quite as good, but I think.
On the shared screen,
on
it's
the
it's
shared
better, yeah.
screen is better.
It's a little, yeah, I think it is a little unfocused, but anyway.
Yeah, so there are tools that can produce like a full application, like Tellurium or Kupasi or V-Cell, can export an omics file if you build something in there. But if you want to take an SEDML file and make a SEDML and create an omics, there's no tool out there except this one. So essentially here, you can say upload a local file that you can select some HTML file, some format. And once you select the format of the model,
Does it not read it from the file itself?
yes,
Okay,
and let me
You have-
actually.
yeah, just do you have
Well,
one? We
the
can just
problem
upload
is
it right
that-
then.
My laptop died before coming here. I had a loaner, so I don't have everything.
You can do from a URI and just grab a biomodels.
Correct.
Go to make SPML, make a quick one,
Yeah,
yeah.
It's just launch composite.
Okay, biomodels. Anybody has a preference? What?
here, I have, it's just kind of random, but I'll put it in the chat. Oh, there. And so in the chat, I put a download link for a biomodel,
Which one?
660. I don't know. I think I had problems with it somewhere, so now it's stuck in my head.
But where? Okay.
Oh, I put it in the chat. If you, or
It
just a
it
Zoom chat.
already downloaded it to me.
Okay.
So
Oh,
when I clicked on the link, it downloaded it.
right, so you should be able to just point to the
I
thing, to
should
local
be
file
able
at this
to
point.
Yeah, so I can select from downloads. Yeah, here's.
There you go, cool.
Okay, and.
Oh, you do have to
and
select, okay, anyway.
SPML. And do we want non-spatial continuous? What type? Uniform time course? What algorithms? Did you have problems with one of the algorithms?
CVOD is probably, yeah.
CVOD. From 0 to 100. And 1,000 points. And you can set for CVOD, you have a number of different parameters. You also see some of the list of which parameters are supported by what, or you can just leave the faults. And
Model namespace,
right, so it
so it
will
populates that, okay,
automatically
good.
recognize things that are listed in the namespace, so in the SPML file. So this is an SPML level 2 version 4. And here are all the values of the different parameters in that SPML file that you may want to change the initial concentration to 2, for example. And you can add by default, all the species concentrations in an SPML are listed as observables. That
Is it all species or all floating species or both?
Probably both.
Probably just all species, yeah.
you know, everything that you see from SPML with those files here.
Okay.
And here are the tools that are supposedly able to simulate that. Blue,
Great. Oh, that's more info link.
Oh, that's it.
yeah, that's the info link. why it's supposed to do that. And
Can you not? Okay.
you don't have to specify.
Oh, you don't have to specify because you're just downloading, you're making the OMAC file, right.
So you can download your OMX file and you get this OMX file that
It's not called,
is, yeah, well, it comes with a UUID.
but not .omex?
But
Oh, well,
yeah, it doesn't propose .omex, but
all right.
an OMX file is a zip file, so you'll have the model in the SEDML that's been created for it. Right.
There it
And you see the data generators, the variables, list of outputs, where the report should be generated, etc.
Oh, by default, it only does reports, it doesn't do a plot.
Correct.
Okay,
By
And was there a
default,
way
the
to, like-
creator only specifies
reports.
a report, but you can create from the UI
That UI?
plots
Okay.
once you have the report, yeah. So you can actually simulate this. And that will move you to the run page, where this OMX file has been, that's been stored at Google, in Google storage.
Hmm.
That was created there. It sends it, or you can, if you have your own, you have downloaded it, you read it up. You load it up. And here,
No, you actually have to
there's
select it.
that you already specified CBOD, SPML, and now you just need to pick the simulation tool and whichever version is available for it. And and just run. Dude. And create.
This is running in the Yukon.
This is, yeah. It's 12 gigabits.
See it.
And it succeeded. And you can download the OMX file that you've used. You
Now,
can
at that point, if you download the whole
model,
project, it would download the outputs too, wouldn't it?
the SEDML, the outputs. Right. Where you
This
have,
is, the content and the simulation outputs, I think, are in the OMX, right?
right, so the output will always look like this. Ah. Wrong link.
Yeah, that's,
I've
Okay,
done that many.
yep. That probably needs to be changed. Fixed, but yeah.
yeah, so you have a zip file that has an outputs directory where you have whatever is specified in the SEDML, and if you actually included some plots, then you will also have a PDF with the plots, but by default, it generates just the report in HDF5 format. But you can actually create a plot and let's say 3 curve, 4 curves. There's time. This axis. I have no idea what the species are, but
But
we'll
whatever.
find out.
Oh, you don't have to re-specify time? Or do you?
Probably do.
Okay,
Yeah, so.
that's good. All right.
But you can do that just writing down the Vega format and uploading, so you don't have to do it like this. And
You it now. There we go.
these are the species,
Take it back.
whatever they did. Okay. Now, obviously, you can automate all of this. You don't have to use the web UI to run all this, and we've started populating the database of published projects. And here is the part that we want to do some changes in the first. You can obviously rerun it, share it, publish it. All those.
If you click rerun, can you change simulator?
So when you click rerun, you can change the simulator, but you cannot change model changes in the SED-ML. That's one thing that's missing. So I will
You think-
rerun it
okay.
with the same parameters, just with
Yeah.
a different simulator. A
That's actually what I would expect the rerun to do, but yeah.
Right,
You just have to save the Omex, go back to the.
To the OMAX creator,
Create-
right, yeah,
the
or
Omex creator,
modify,
you
yeah.
load that, yeah. So-
right. So ideally, you should have an easy way to take something that's already published, because there's many. Which are here. Here.
You have to go back.
One tab to your left. Keep going, one more,
One more left.
There.
find simulations.
And when. Here you can browse existing ones. And if you have like Alan, blazing new map. With lots of RAM or whatever, this will actually load up in some decent amount of time. But on my lower laptop, that's an entry level Dell with little memory.
It takes a little bit,
Um,
but not for long. That will change.
it will eventually.
Well, like, and in a few weeks, it will no longer have this
That
issue.
will no longer happen like this,
There
but
it is.
eventually. You will. Find all of these existing projects. A, license paper from 2004. And if you select one of them. You can browse through this. With information about the model, when it was run, and you can actually look at runs from these published models that are all saved on the database that was run with open core. Because this model came from the Physium model repository, and here you might or might not have, depending on the model, built-in chunks. Now, in order to navigate through this easier, on the dev site, so if you go to our simulations dev,
This is still very.
Hot off the presses,
right, all of the presses.
still going to burn your
We
fingers.
Started reviving the backend architecture because it was not maintained since last summer, and a lot of things changed underneath. So then the CI/CD pipeline and the automatic building of all these solvers and websites and everything no longer worked. And it took quite a bit of effort to bring it. It all started with a Python change in NumPy that broke everything in July. Including validation of new simulators and whatnot, and we simply did not have the resources to go and fix things then. And then as time went by the time we had somebody to work on it, a few months later, there was a lot of other things that were open.
Yeah.
And automation is really nice, so I'm just gonna give you a quick anecdote here. A couple of years ago, when Jonathan started putting all sorts of automation in the biosimulators and biosimulations repositories, the virtual cell has a very complicated deployment procedure where you have to compile the Java code, compile the non-Java solvers, create 7 different Docker containers for the swarm that runs the backend for the virtual cell client server. Use one of those containers to actually build client installers. Then do various signing, notarizing, depending on Mac OS and Linux or whatever procedure for the client installers. Then go and log into the master nodes of the Docker swarm, replace the existing swarm, put the old one in, go to the website where you put the newest installer so the client will detect that there's a new one so it can be updated. So that was very, very tedious. And I said, well, the one developer was doing that at that time. I asked Akil, it's like, put this into GitHub Action, just chain the whole thing so we can deploy automatically on every tag and recompile and do all that. And a couple of days later, he gave me 2 weeks notice. But it was not related to
Like, I'm not doing that.
it wasn't because of that, but that was just a coincidence. So he left. And then we hired somebody else a few months later, but it turned out not to have all the skills that he was saying that he had, so I let them go. So then, another couple of months later, I decided to do it myself. I haven't looked through the procedure for a long time, and I looked through all that, and I discovered that one of the steps, and it's all automated steps, but it was I had a lot of fun putting this into GitHub Actions, and I think I have this here somewhere. In this whole multi-chain jobs here, there's one step.
This is a workflow.
Yeah,
That is a long workflow.
yes, and multiple steps, and one of the things here for the map, what we need to do is to run a stapler. It's a security thing on notarizing and
All right.
signing and whatever, which reminded me of a nice cartoon on how modern software engineer design staplers. Which if I get to zoom out here. And this is on sound physical principles, and it works every time the new tag that's signed, gives the signal, compile and staple the damn thing. And it's fine if you exercise it, if you staple things every day and something breaks, then it's easy to find out what broke and what fixed. But if you don't use it for 9 months, and you just find it doesn't work, like what changed is now did they change it to a smaller scissor, or is the string thicker, or is the bucket of a different dimension? All those things change.
Yeah, imagine each of those things as a different Python package maintained by someone who is not you. Right?
And Jim went through the exercise of, finding everything that has changed and eventually fixing it. Which I think it was a fun project.
we should talk a bit about the UI, mostly
And
for.
that, and got to the point of actually being able to implement changes, but because of this, what we did is it takes a long time to start making changes. So in order to properly prototype a new user interface, it's easier to start with a smaller project from scratch, which is what Joe did, and come up with whatever the new UI and improvements are there, which he will show later. And I'll just end here by showing how far we got, if I can get this out of the way. Okay, so. Oh yeah, I need to.
Need to go to New Zealand.
I need to check. So, the dev site. Browse, and it comes back instant. That was the first thing that we agreed that it should be immediate, and having a little tabular view makes it easier, where it can have like a shopping site, you know, show me 50 results per page or whatever. Here's 50 results, and
The search is on top.
and the search is actually on top, not like on the other side where there is a button where it will pull down filtering, which you first have to identify that it exists there. But then the search is on bottom, and even for the biggest screens, because there's so many things by which you can filter, the search will fall below, and you wouldn't know that it is actually there. So, you know, search, okay, Warren system. From Alan. From Physium repository, you can select the chart. And get the plot in everything in just one click. And I was actually able yesterday at dinner to rerun this from my phone.
Nice.
And resimulate it. And you can take also directly your data out into those people who are fans of Plotly, into the chart studio, and get all the data there and create other charts. In
Can you do the S1 versus S2 for this?
what?
Instead of plotting versus time, plot the two variables against each other. That's where you see like the Lorentz attractor circles, right?
Yep.
Hey, there we go. Oh, it plots it on the same graph. That's funny. But okay.
It kept the other one.
Yeah.
Oh, I see, there's multiple curves. You can probably X out of the ones above that. Yeah, that was just X. Yeah, there we go.
I want to only see that.
Yeah. All right, nice.
So Alan, what does this model actually try to accomplish?
What is the Eran?
It's just the original orange color. Okay. Right, so it's still complicated enough that we're not going to make quick changes. So design and prototyping are better than outside the framework, and then once decisions are made, start putting them in. And we haven't changed yet the main left to right paradigm of going from list of models, all description, data plot. So that's where we are right now, and Joe,
Gonna
Yeah, I
show
can show you a few things. I think one thing that I feel that you sort of understated is that the biosimulations has a really nice set of APIs. And I think there's, some places where there's some documentation that could be improved. But overall, I mean, you can get a whole bunch of stuff, which makes it very easy for someone to build something on top of it.
exactly.
But it can't, there are issues. 140 seconds to get the list of published papers, a bit long.
Well, oh, yes, right. So
There
how
are
you
issues.
Yeah, okay, so it depends on how you want to use it. Now, both, what I did and what you did as well, is you divided if you build something new, you have two parts.
Right.
The first part is something that does pre-processing and gathers together all data for exactly this reason, that it's not necessarily that responsive. And as we add more simulations, it's probably gonna get less.
No, it's the design that's not responsible.
No, but this one, like, it's all, in the database indexed, and the
No.
server side will, the API will get you back.
No, the design is not responsible.
Yeah.
The way it's doing it in two ways. You have to get the metadata, locate another thing in the metadata, then get the. model.
Jim, can you?
You have to do that.
Yeah, no, I can address this a little bit. I mean, when you're using a relational database, you denormalize everything and you do joins and selects and it doesn't, how you use the data and how you represent it are kind of independent. When you have a document oriented like Mongo and some of these things, you really want to design your collections. It's okay if the same data is in multiple places, but you want to design your collection so that they're convenient for how you're going to use them. And I agree with Joe that the current representation, it begs for grabbing the projects and putting everything and only what you want in that collection and create like another collection that's
I mean, the reason it wasn't designed for this in mind, that's why. That's the reason. Jonathan
sorry,
never
what?
saw the reproducibility side, he saw it as a model composition side.
This last page is supposed to be a project explorer where we accumulate published data. So from the get-go, it's supposed to be an explorer, but it wasn't completed. There was still some.
No,
We're still working on it.
it's
Well,
not
this is
designed
fine.
for papers and grab simulation for papers. It was, the API wasn't designed for that.
right.
We know that. Me and Joe tried, we tried this, I've tried this anyway, I even timed how long it took.
The
140 seconds to pull
API
the data
was
back.
designed way back when, and indeed,
Yeah.
the purpose was to run. That was the first thing. To be able to run with multiple things. Putting together a collection of published projects
Yeah.
came last.
Yeah,
It
yeah.
was,
Yeah.
packaging simulators first, API second, running third. That was kind of the order of development, and then the UI, the browsing, and the plotting also came later. Jonathan, I think it might be online. So all the time.
Well, I was there.
Hey, yes, so I can actually jump in here because I designed the API. So definitely agree that it is not at all optimized for the use case of actually browsing all of the models as a sort of collection. So what it really was optimized for was essentially being able to break down this whole kind of workflow that we were thinking of into these distinct phases that we could then just do a post from the HPC onto the database. So it's more kind of like, optimized for the actually getting the simulations running on the HPC and then putting them into a web-friendly format. So on top of this, I think it would be really nice to actually have like a specific, Mongo collection that's just a projection of the others that are now actually formatted into convenient data structures for browsing and viewing and exploring. So that I think would be probably the best approach to take on how to address this. Because the size of the database is going to continue to grow, but you don't actually need to be hitting the API just to browse things because that data is already available over the long term. So you can just keep essentially rebuilding statically hosted web pages that are just templated off of this information. So you don't need to actually pull this data from the API on every page visit, for example.
It's not as dynamic as a true shopping site where products change every day. Like we maintain the actual thing. So
Yeah, because the biggest cost here is like when we run simulations, like when we were populating the database, we were, there's like 1,000 or so simulations from, biomodels and cell physiome alone. And so, we're trying to keep everything as this sort of like immutable sort of records of runs. So those are really sort of optimized for just posting this information. But then once that information is posted, they're not going to change because all of our IDs are designed to be permanent. So from there, we can just statically generate web pages to actually do the displaying and visualization.
To be honest, the API that exists, it needs use. Right, it just didn't quite do what we wanted it to do.
Yeah, I think where I found gaps is when I got to the point where I wanted to find data. And so like, okay, and there are these HTF5 files. Well, how do I know what the values are for the data sets? What are the names? Well, it turns out that was actually very nicely done. It just wasn't documented in copy display. So it actually was well structured and it worked, problem. But there are just some small gaps in documentation in terms of actually using,
Yeah, I mean, I think some sort of a higher level methods that are not so resource based and so siloed to accomplish some tasks would probably help.
I think identifying the gaps in documentation is best done by someone trying to use it for a purpose.
That's the best way to do it.
So please, I hope you wrote some of this down.
Yeah, I can certainly pass them on. I can show you just quickly what I've got. If you want to let me share.
yeah, it will automatically be.
Okay, great. Okay, yeah, here we are. Okay, so it's pretty much like what that last sequence of screens was like. It's just all together. So there's a search bar up here. And by the way, I have to say, I mean, this is something I put together quickly. It's not beautiful. It's intended to be illustrative. We have somebody else who's going to make it pretty and more full feature. So you can search like Google search. I'll show you that in just a second. This is much like your first page where you get to pick, your titles, just limited the scrolling there. What happens is once something is picked, you get the research summary over here, which is the abstract. This was done offline. Not all these abstracts were in PubMed, so I used, of course, ChatGPT. So you can decide whether or not it's a hallucination or not, but see if it matches what you think. Then you get a plot over here. There may be multiple data sets. So it picks up the first one. The idea is ultimately you'll get the selected fit set if you care. And then you can actually even get a view of the model. If the model is actually something that could be translated into antimony, you get something that's somewhat human readable. If it's not, you have the choice of looking at XML, and XML is your thing. And then you can do, one of the things that I thought was sort of useful was if you got a chance to see, how many articles in your selection have your keyword. So you can do this type of thing and glucose, that type of stuff. You can go over here, then once it actually picks it out, it will go over here. I guess sometimes it's a little less responsive, which is okay. Actually there's only one here. Oh, okay, so you can see it over here. So you actually there's a many variations on these packages where basically you can do Google searches on a corpus and then highlight the text that's present in the article. And the idea of one of the things we want to do is make this so that then you can get the abstract, but then you can also actually get the entire paper. Right now, there's a link here where you can go and see the entire paper. But the idea was to try and put it all, together in one page, so you could have, a single frame that you're actually looking at. So that's sort of where we are right now.
When you said when you were looking at the plot, the plots are available as PDFs from Biosimulations or Biosimulations. Are you showing the PDFs or are you actually doing something
I'm
else?
doing plots. What I'm doing is I'm going to the HTF5 file
and just showing
And then, and
a
then
set of
picking up
data.
the data from there. And I mean, we could actually, I mean, that's another possibility. We have a window that shows PDF files. The question is, what is that? You know, what are the semantics of
Yeah.
what it is that was done? And not to say that, you know, by showing this with this CSV file, that not great with semantics, but these are either 0 or 1. It's probably a logical model. So.
No, we want an
The
interactive.
abstract in the description, our original goal was and still is to actually include that in the database as opposed to the biosimulation.
Yeah, and that would be, right.
And some of them have them and some of them don't.
Okay, so one of the things we'd like to do, we want to sort of build on this idea of linking together sort of an NLP kind of analysis with the data. So that one of the things we like to do is when you're looking at the model, then be able to navigate to the part of the paper where the model is described. So you can see together the model in the paper, and then hopefully there's sufficiently descriptive information about what these variables are. So, you know, some of this is a little less descriptive, maybe specific to actually the SEDML about what's going on there.
That's why we need an interactive plotter there. That's why we're having an interactive plotter,
Okay.
because you have a situation like that in the PDF, that's not gonna help anybody. So
Yeah,
you have to
well,
be able to select and unselect, plots.
you would want to, the information is in the SEDML. I don't know
Right,
who
right,
needs to parse the SEDML. Like, I can imagine putting a SEDML parser on the server side and the REST API, like, what is my graph? But it's all the information about what you should show is in the SEDML
Yeah.
as far as the plots.
So
So
basically,
we have already parsed the SEDML and converted it to
Right.
JSON. It's in the database, so it can be accessed.
So that
from,
should be, yeah, that should be.
the endpoints.
So by parsing the SEDML, what information will I find about the plots?
What to plot? What
Well,
plot
okay, so,
against each
so
other?
actually, when I'm probably and I'm approaching this from the point of view of a user interested in an article trying to dig down to the model. Yeah, I'm gonna be interested, okay.
I mean,
so
ideally,
what are the
the
conditions?
plot is figure 3 from the paper.
Yes. So
That's what it's showing you. It's
Yeah.
showing you, like, in an ideal
Okay.
situation, it is actually showing you a figure from the
The only
paper.
problem is you have to read SEDML.
No. So Bilal says, everything is parsed into JSON. So there should be, if there isn't already, there can be a REST API to just grab that information from this.
So maybe you can give me more details about either what API or what
It's
file.
described
that
in,
you're
I think
looking
it's
at.
described in HDF5. I've seen it in the HDF5.
Also,
so the HDF5 will
Somewhere
have
else.
entries for each of the entries that are specified in the SEDML file. And the SEDML file has two classes of outputs, reports and plots. And the plots have entries like plot 2D, x-axis, y-axis.
Yeah, but the problem is how to get that information. We know it's in there.
Well, so help me a little bit here, John.
Okay, so how do you query that across projects?
Well, that,
How to get the
that,
information.
I get that already. I mean, that's not too far. There's an outputs file that it's zipped and then you can unzip it and it has a lot of the details in there. But I guess it's maintaining that the information I was interested, which was really relevant, is then that if this particular plot is named figure 3, that actually be figure 3 in the paper.
In theory,
yeah, in theory, it will be, yeah.
Theory,
So this is where like this is not a technology problem anymore, but it's just a curation problem. So if we
That's a
do
curation problem.
Still,
metadata-
problem. How we gonna get this in?
Sorry?
I think Bilal has the answer for you. Yeah.
Okay.
Yeah, this sorry, I can't hear the rest of the room very well, so I might be speaking over people. But yeah, so this is where this is not really a data access problem, but just a curation problem. So for
That's
the
what we're
most
talking about.
models, we don't have things properly labeled as what the figure is. So with the curation project that we've been doing on biomodels, if you just we're starting to like encode this information into the metadata, like the omics meta format RDF file in there. And then that's exactly what will happen. You'll be able to see a list of visualizations, and a particular visualization would correspond to a particular figure in the associated.
None of this answers the question.
Did you say earlier that you have parsed the SEDML and have that information in JSON format?
Yeah, it should be one of the endpoints, I believe. Let me take a look. I haven't seen it in a bit.
That would be it.
Right.
Yeah, so there's a specifications endpoint So that actually returns essentially the SEDML specs roughly translated into JSON.
Okay,
So if
Okay,
you just
so,
do a
yeah,
get
yeah, I mean,
specification / some ID of a run.
no, it's not a SEDML file, it is the parsed SEDML file in JSON format.
okay, and I get this through what API?
Yeah, which endpoint?
The specifications and,
At specifications endpoint.
yes,
Okay.
yeah,
So if I can,
Yeah, because that was my problem. I mean, the only way I knew how to do it
was to parse the.
no, I dug into the HDF5 file.
Oh, the
Yeah,
HDF file,
well,
it's there also.
then you-
Oh, yeah, okay, good.
I think if I could go over,
You go over? Okay, you
is
go
that, so this one?
Yeah.
This one, all,
yeah, so you won't be able to call it on the whole list because that, but you can call it like for a particular simulation run.
so I should be able to do that here.
Yeah, so what does it take, a run ID or?
A run ID, yep.
Yeah, okay.
Am I able to do that here?
Yeah, you should have a try.
Oh, there it is.
Yeah, if you have the run ID, I can give you a run ID.
Yeah, so the access to the getting the entire database is restricted because some of these are like corresponding to runs that aren't published, right? But we should be able to do it on this document,
Everything's public.
the next endpoint. Like for the
Here's a
particular-
valid run ID.
Oh, I see, okay, so I should go, I see this one,
Yeah, so there's no lock on that one, so.
and Joe, you put that in chat.
Yep.
Yeah, right.
Ooh, can I copy this?
Yeah, you
Should be able to, yeah, you can be able to.
You'll have to hit try it out first. It's a weird quirk of the UI.
Yeah, right, with, push try it out first,
Try it out.
and now you should be able to copy.
Yeah, I don't know why they have that there. We didn't build this product here.
But the response bodies below.
Yeah,
Okay, so let's see what we got here.
So I mean, this is roughly the SEDML, parsed into
Yeah,
JSON.
yeah, enter output, the data sets, okay, so. SEDML, okay, so what I'm looking at here are.
well, there's all your data generators,
Okay,
and then under the data generators should be the plots presumably.
yeah, so let's see, right.
So like in this example, you're actually seeing labels and the plots because this is a well curated. But if we were just parsing out some SEDML or some XML that didn't have metadata associated with it, we wouldn't have those that information.
Okay, so name figure 3D, for example.
Yep.
If that, now that should relate to a paper. And then what is the file associated with figure? What are the files and data associated with figure 3D? Can I see that somehow?
So why is it? Why?
Oh, okay. So I mean, so these were the specifications that we put into the simulator, and then the simulator would have output matching files, right? So you're saying you want to be able to get those.
I mean, the matching file in that case would be the PDF, so I don't think that's what you want.
That's fine.
You want to do it from here, right?
I have a preference for actually having the
Right.
data itself, but it's not mandatory. The most important.
But this, so if you want to generate the data yourself, this is what you
I don't
use
want to generate the data. Well, in terms of, yes.
in terms of actually plotting, right?
If
Yeah.
I'm
So
plotting, I'll be-
you just want the raw data to plot, because then that's the results endpoint. That's the next one on the list of grouping endpoint.
Yeah.
Yeah, I would exclude one versus the other, but from this output that, Eran generated there, I see the name figure 3B, that should correspond to the paper. I should be able to search the paper and find that. Can you show me where in the JSON it will tell me what data and what
That's-
plot?
that's-
That's the data.
The Y data generator and the X data generator.
Probably go up here.
Okay, so there's gonna be a file called data_gen_FEDU.
There's not gonna be a file, there's gonna be a data generator called that.
And
Okay, so I need a file.
Yeah. That's fine.
It doesn't do me any good unless I have a file.
Exactly.
The
I mean,
file,
there's
if you
also
want the data, that's an ATF file.
Okay, so in the HDF
The file is all-
okay,
are all
there
these
there
things,
would be a collection.
it will be a collection with the exact name of that plot. You'll see figure 3D.
Okay, that's fine,
And
okay,
under
okay.
it, you will
Yeah.
find the individual.
Okay, so actually, at that point, I don't even need this. I can go to the HDF5 file,
Exactly.
I look at the collection,
Whole thing.
Okay,
each
yeah.
collection should correspond to, and that'll be.
But if you, at one point you wanted to like simulate yourself or like
No,
change
no,
things,
no.
like at some point, okay.
That's beyond.
That's for
Okay, never mind, yeah.
You can
Yeah,
parse
yeah,
the API file, but there is also just an endpoint that'll give that to you. So the next one is results. So if you put in that same ID for the simulation run into the results endpoint, you should be able to get what you're looking for, I think.
There's results here.
Yes.
Ah, here we go. Over here.
Yep. So I think this is going to give you everything you're trying to get. So over here, the reason like there's that include data parameter is if you hit false on that first, that'll just give you, here's what the structure of the data is going to look like. And then when you include true, it'll actually give you the large, arrays. It's easier to demo if
I'm
you
looking at it right
hit
now.
false
Got it.
first.
Yeah.
And then the next
Okay.
endpoint, yeah, if you let's keep that. So this is giving you like, okay, here's what the structure of the data is going to look like, right? So you have a 2D plot. Here are the various, x-axis, shape, all that information, and then you'll see values.
Yeah, file.
Yeah, so
Yeah, but you can get it directly as a REST call without
let's-
having to download the HDF file.
Let's-
If I need the data.
Let's try this.
You can-
but
you
now
can-
if you can include data,
Oh,
it's going to be a little bit slower because
Yeah.
it's including the entire data set,
Yeah,
but now
I-
it'll have the values filled out.
Ah, okay.
And now, yeah, so yes, it's
It's just the reason we have that query there is exactly to avoid this, because this page is not designed to have these large arrays displayed, right?
Okay, that's maybe what you need.
So, okay, so help me here. I don't have a problem with parsing HDF5 files.
Okay,
Okay, HDF5 file, it's really, Python provides great support for this.
oh, good.
Yeah, so, I'm trying to think of why, is there something I'm missing for the reason why we use this API? So I can find that the name of the collection corresponds to the name of the figure. I've got the names of all the variables and
It might be-
I've got the variable name.
Maybe speed, I don't know, like, if you get the HDF file, you have to get everything.
It's all pre-processed.
Okay,
Oh, are
then-
you asking like, is there anything
Personally.
this API is
Personally.
providing
Yeah.
that's not accessible from like just the underlying running a simulation and parsing the output?
And just think of it, because we're thinking only of a typical small situation. What if the HDF5 file is 2 gigabytes? You're not gonna download that first in order to look at what the things are.
Right. Now, you're not gonna do that in a user interaction.
Right.
But if you have pre-processing, that's another story.
Correct.
So Joe was just wondering,
The API is very much like intentionally designed to present to you the exact set of information that you get out of the simulation run going through a biosimulator. So those are identical. There might be, some issues with translation where we, might have a couple of bugs with how it's going from HDF5 to JSON, but you should be able to get all of that information in either situation.
I think so. It's all one. It's just
Unless you're all.
another REST API. All
The HDF5 is actually pretty straightforward. It's not very
okay.
okay,
Thank you, Bilal. That
Yeah, thank you, Paul.
That was
for
helpful,
explaining that,
yeah.
and also
bing,
for-
bing, bing.
Yeah.
The main thing to me is this correspondence, the names generate the font and the actual figure in the paper. Because that's gold. Now we can locate where you should be in the paper when you're looking at this figure.
Yeah.
Because that's the ultimate context you want. I mean, it's not just the variable name, it's also what is the figure, what's being proved here,
Right.
Yeah, that's great.
So and I can also,
Very few are curated like that. Right. With descriptive names. Or
Well-
the plots or.
about half of the biomodels are.
I mean, ultimately, you want to look at the paper.
But so I can tell you about half of the biomodels, once they get in there, will be done that way because there was enough composite information. So there actually is like figure 3B or something.
Because you
Because
you spend the time to.
you pull it all out of composite and everything else, right? Yeah. So,
Right, and that, to me, that's very powerful, because then if we have the data there as well, whether it's through the, the endpoint, or it's through, looking at the API
Right.
file, if they're gonna press download and get a CSV with the data they're looking at for that figure, that's fantastic.
Yeah.
Now they have something to build on.
yeah,
But then you have, so we're gonna put all the, 800 simulations from resell published models that are published papers, right?
Mhm.
And what we do is like, we don't have a curator. And people publish their models, and some of them say simulation 3 is a parameter scan, and they name it figure 3D. That's the happy case. Okay. And they have maybe 5 simulations, some regular, some parameter scans, whatever, in the model that's associated. When we export and upload them, all you're gonna get is the name of that simulation and its figure 3D, but you're gonna get every single variable with every single data point in that.
Right.
And nobody actually went to say that figure 3D is only displaying calcium and against time.
Right.
So that is, it is missing.
Is that in the composite stuff?
No, we're not talking about malls. I'm talking
No, he was just wondering if
about
there was a difference in the
We
quasi.
know how it's created, right? So
Yeah.
it's whatever the users put out there, we spit out everything.
Right, so because there was a curator that made the quasi file originally, and because quasi file can export SEDML, then we actually do have it for half of them.
It
So-
took them what, 15 years to curate 1,000 models.
Right. So, yeah. And I can say,
half of them were-
yeah.
So I mean, but a lot of investment that went into the engineering work we did here was actually to make a lot of this completely automated. With the idea being that the amount of time it takes to go back and curate and put all of this metadata in and ensure that we can like accomplish this vision of, you know, being able to link data directly from papers to figures and explore further and then change parameters and run it again. It's just going to be a huge investment in curation. So with the tools that we were demoed earlier by Jan showing like how you actually download that Omics archive with the SEDML already filled out, the whole idea is that by using these, all that metadata is in there, and going forward, any project that's created using those tools or is run using the entire ecosystem essentially has that built in. So it's more of like in the future, as long we can make it very easy to include this metadata and, you know, start encouraging the journals to, you know, maybe publish it, require, you know, having run through a tool like this, or when people publish their papers, they just include a link to the actual run they're talking about, so that we don't have this curation problem. It has to fundamentally be the authors who are putting this information in as time goes on, rather than having to go back and curate, because a lot of that data is just gone, right?
Yeah, and back curating, it's something that we probably don't have the bandwidth to do, and we'll populate from sources with as good as we can. And at some point,
I can imagine.
Populate is to encourage.
unless you bring some magic,
Well, but the reason to do it is to encourage and persuade authors that it's worth doing.
You know, I can imagine sort of guyish scanning a paper for figures, reading the axes and the legends, and being like, I'm guessing that this is probably what what we're looking at.
Yeah.
And I think so that sort of automatic generation of the SEDML sort of thing is
A
probably
year or two away.
yeah.
5,
Say that again.
no, SEDML.
Someone.
Yeah, like at Combine in Berlin, someone like was literally doing something very close to that. Yeah. Was trying to, they were focusing on annotations more than figures, but yeah, was scanning, reading papers, trying to figure out what they were talking about, finding the annotations from those things.
There's
Yeah.
another possibility here, a feature, if it sounds interesting, and that is that through this UI provide feedback to say, look, I found figure 3. This is the one that should be associated with these data. And so, you know, we could figure out a way to
Yeah,
provide
that-
feedback, if there's a way of getting that, you know, into the curation.
Back from the, back
Yeah,
from
that
the
would be
users.
incredible. If the website
Yeah.
had a built-in community editing or you know, community curation tool as well.
Yeah, and if you want to think about what the website, you know, what does that mean on the website side? We'll think about
Right.
what it means.
Yeah,
That is all for backwards curation.
yes, the retro,
Going forward, just tell us what.
Just do it here, like, make your figure,
Tell us
yeah.
what's there.
So yeah, I mean, going and doing curation backwards is just, you know, it's a not a technical problem. It's a matter of just, you know, bandwidth. And then going forward, doing curation properly and making sure that everything is annotated is also not a technical problem. It's a political problem, right? We have to encourage the community
There's
to
also
approve those
like a good
annotations.
UI, like
And-
political plus, make it
Yeah,
very.
and UI that makes it easy, absolutely.
Yeah.
So the tooling definitely needs to improve, but in terms of like what will a paper that is published in a journal have enough metadata to link up to the original simulation is not something you can really control outside of the journal, right? Like the journal has to have some enforcement of providing a link to a reproducible run or archive that has all this metadata.
So I have a question for you, Bilal. One of the, most of the things are available right now through their REST API, but the one thing that as a user, I would like to see, which we don't have right now, is so step one is exploring, and we can improve and do and explore in many different ways. But once I explore a model and I may be familiar to that, the whole idea of reusability, as we put it there, I want to rerun the project after making some change. How can I, except without writing Python code, have a button to pre-populate the editor and creator of SEDML project with an existing project data?
So that was going to be the next endpoint that I was going to work on. But so it's a two-step process. So what you can do is you have a given simulation run, you can download that Combine archive. Then there's that second endpoint in which you can upload a Combine archive with a list second endpoint, we can upload the Combine archive, get back a list of all the model parameters and on the initial values of the initial values of the parameters. And then there's a third in which you can upload that archive with the changes that you want. So that all kind of needs to be wrapped up into one nice convenient endpoint that does all this.
I don't think that needs another endpoint. I think that just needs a linking of the existing, because I can do this by going 3 steps manually, either from the UI or using the existing endpoints. So I think with the existing endpoints, you can have implement a single button click on.
In terms of a UI, yeah. For the UI, you could always just do this chaining in the logic of the page.
Right.
That's
Yeah, so that was sort of the next task was to and like one of the last open issues on the repos, implementing this kind of workflow as a form that users can do really easily. So like just how there's a button to kind of rerun, that button should actually, well, it takes you to that form in which you can rerun, and then there should be another kind of subsection there that lets you edit the parameters. So that was
So
going
we
to
had
be
a whole discussion with Jake Beal earlier about, reusing, rerunning, reusing. You could say, rerun means run it again with a different simulator or whatever. Reuse is open it up in the project editor, where I can make a change. Run it for longer, run it with a different parameter value or whatever. So I would envision just two different single click button actions.
And we've been working on things that will like pop up the simulation and it's live. There's slider bars for the different parameters and you just change them and it does the simulation, right?
Yeah, there's a couple of examples of those, I believe, on LibreTexts, it's like an open source textbook. So this was a project, wasn't this in collaboration with you, Jan? You were leading this. Yeah, so there was one of the biochemistry textbooks has like, Hill's equations and enzyme kinetics as exactly this, where you can tweak those values and just very quickly run and get back the results.
Sliders there, which is the
right.
everything. But it's not truly in browser. What we're thinking here is actually used
a number of tools
for the real simple models truly in browser running.
Oh, okay. Yep.
Yeah, in browser. Yeah.
That might be possible soon with WebAssembly.
Oh, it is
actually, compile some
done it.
some of the tools down in the native browser.
Yeah, we used Inscript and have done it. So
Yeah,
it's live.
Yeah.
We have demos.
Yeah.
Yeah.
Oh, wow.
So, but it's more prototypal, although it's not bad. So, but Jan and I are going to try and put together a proposal to greatly expand that.
And being able to export as an OMAX archive would be an interesting, not for LibreText in particular, but
Yeah, sure.
but yeah.
Well, it's all in hand. I mean, over the years, we've been getting ready for the web stuff. We had to get libSBML ready for the browser. We've got Anthony now ready for the browser. You know, things like that. Kyle has a demo of a simulation, in-browser simulation, just to show off libSBML he put together a couple of years ago. So we know how to do it.
Yeah, libSBML native on the browser would be very nice for avoiding a lot of the API calls that
We
we have.
we have it. We actually have it.
Yeah.
So you don't have any, when you rerun with new parameters and new settings and new time slots, you don't have any ability to rerun it with an additional species, or an additional reaction for you.
That's model editing. We don't
Right.
have model editing right now.
Right.
Only simulation editing. So that form, yeah, I probably showed you before you came in.
All right.
Online form where you can select the algorithm and time course and changes to species. But not add XML or change XML, which
So it's really interesting how you said XML there, because that is exactly why we don't have this feature. It's
Right.
not limited to XML-based models. We also use this for models that are not based on XML. So that's why that is specifically excluded. Was
I know, I
because, you know, if it was a
understand.
JSON model, I don't know if anyone has JSON models, but you know, various different formats that are not XML based, like WoolNet, I think, we can't use that. So.
I mean, the other issue is that no one does it for XML either, but even though the constructs are there, but because I don't know, it seems to be fundamentally the wrong approach.
There's already sites that let you do this anyway.
What?
JLib
JLib SEDML? But
SEDML doesn't add
It
XML,
can, well,
delete XML.
but no one uses it in like in an actual, no one has done model editing, right?
We
Oh,
were
okay.
discussing this feature, and at some point, you know, we just came to the idea that if you change a model, it's a different model. Make a new archive and upload.
Was back then because it had to work with SEDML.
I mean, does Copasi, when you delete a reaction with Copasi spreadsheet, do you go to the XML, delete from there, then reload the XML so it reappears?
No,
Don't really do that, do you?
But
Right.
see,
I wonder why.
SEDML was meant to be model agnostic. So the only way we could have any changes at all was based on XML manipulation.
I mean, the other way to do it is
But that
semantically.
Still
But yeah.
restricts, as Bilal pointed out, still restricts it's model language agnostic, but it's restricted to XML languages.
Which was
for
okay
that
back in
feature.
2005 or 2008.
Yeah.
These are, I mean, I agree that these are very good reasons to have used expats, and
No.
I think it's good for
No,
XML-based languages, but yeah.
Oh,
right now,
4:30 is the break.
right now, it's
Right
afternoon.
now,
Those
it's
bananas are waiting for us.
If anyone wants bananas.
Bananas.
Oh, there's coffee there.
There's still coffee. You guys didn't drink it all from the morning, right?
Drop it to the microwave.
Okay, so I think we covered. That was good.
So I have an action item for you then. I think you should start fleshing out this station forward you have.
Yes.
Single models, no ports yet. You already know how to add those.
Yeah.
How can you do all these use cases? Obviously, you have to expand the JSON tree that you already got. How to do all those use cases?
Yeah.
It's the competition, of course, with the original proposal.
Well, in concert,
It
hopefully,
doesn't
but
matter. I don't know what happens where, but you might want to get together.
yeah, yeah.
Drop something out.
We've chatted. I don't think there's gonna be a lot of,
Okay.
I mean, the information that needs to be stored is the only issue. Like how to store it, I really don't really care ultimately. Like as long as the information that we need is
Yeah.
there, that's the main thing.
Yeah, I think to start, I can build a prototype. We need probably just a few tools. So let's go back to.
Yeah, we can probably type stuff on our end as well.
Yeah.
Yeah, I mean, so we just need, we need to put
Once
it
you
in
have your
here.
format, right?
We need
Try
the,
out.
but we, you know, all you need to do is. We need to get the tools.
As far as I can tell, all your I mean, I think naturally of your ports as your function arguments and your function return things, right?
It's just.
So basically, that's what it
Oh,
is.
I see, you want to reuse both connecting analysis
Yeah,
together.
a
Yeah,
port is
right,
like,
right.
so if you have a function, X is a, you know,
Okay,
given
yeah,
type,
So, yeah,
there you go,
yeah, programmers, yeah.
there you go. Y.
I don't understand the colon, what is the F?
Function,
Oh,
here, yeah, yeah.
okay, I'm sorry.
So this is, so here we would have two ports. X is a port, Y is a port.
And why is the return value?
Why is the return value?
Okay.
All right, we'll see what it looks like now in your JSON format. So I
Yeah.
want to make it too chatty and
Yeah.
verbose.
And this is pretty much it, so. You know, we also want like an address, for like where we're gonna find it, or a location,
Fine, well,
your parameter estimator. Like what parameter estimation tool do you wanna use here? 'Cause we-
Oh, so for SEDML, you would just say a parameter estimator, and then a SEDML interpreter would then say like, okay, I'll pick this.
That would be like a particular instance of.
Right,
So
right.
you could define the schema, and then an instance of this would be like, you know,
Right, like now I want this particular thing.
Yeah.
Although I can imagine sort of encoding that information sort of on the side in SEDML, almost with annotation, like when I ran this last, this is the parameter estimator I use. But any parameter estimator should work.
remember, parameter estimator is a separate application. This is going to be very fragile.
Well, no, I mean, like-
In about a year or two.
But
However, if it's asking for the optimizing for Parsi and it's running everything else in Parsi, it will be very robust.
yeah, but then you can't swap pieces out.
I mean,
Now, you can get another tool that also includes a simulator and an optimizer.
all the SEDML has to say is simulator and optimizer, and maybe I use Copilot for both, or I
Avoid
use
workflow
whatever.
type.
Yeah.
Why the workflow type thing? Because they break so easy. The application may no longer exist after URI use specified, or they mean. I
Yeah,
don't even know what that means. Does that mean they have it on their machine? They don't have to be downloaded?
I mean, I was thinking almost like a high package, you might, you know,
Ah,
like you might want to download it, it might be even low, maybe you,
maybe that's the thing.
and you, so you can have your address be like an actual high.
Whatever you do, you gotta make it robust to the future.
Yeah.
That is about visibility. So
Yeah.
I think we should have at least a 10-year horizon. Where it should work up to 10 years.
Mhm. So we might want extra annotations, like
That's when-
what we're.
gonna retire?
Yeah, wonderful. I mean, that's about a 20-year horizon so far.
Okay,
Not
so
bad.
we'll make it
Eventually
last
it'll go up to 30 years.
at least as long as SDML.
Oh, no, at least 10 years. NSF once said 10 years.
can
I
use
think it should be available after 10 years. Okay, 10 years.
lasted longer than that.
Yeah, so the problem with one environment with everything in it is, of course, those things also go out of date.
No, it's not the environment, it's just that the SEDML is agnostic about implementation. It just says, I want a parameter estimator, I want a simulator. These are the general
Yeah.
algorithms that I'm
So
using,
that's.
Right.
Yeah, so the idea is they will load one of these then into their favorite application.
right, and
And
then.
it'll run it, and then it'll say, oh, by the way, you can't actually do parameters.
Or something, yeah. Yeah.
Okay?
Well, it would need to be of this type, right? So it means you actually need, like, if I'm pulling something in. That is a parameter estimator, then it needs to say, where does the input data go? What model are you using?
Well, if it's enough, I mean, I imagine something like Parsi would load this
Mhm.
from a menu, right?
Yes,
And it'll go through this and know exactly what to do.
yeah, so that, in Copasi would be like, you know, some local Copasi, use your.
No, it doesn't need, Copasi is loading this file,
Yeah.
so it doesn't, so you don't need
you
anything.
don't-
Copasi-
You wouldn't even need that, it's like,
Right,
it knows
right.
what the parameter.
It knows what a parameter estimator is,
exactly,
right,
yeah,
right,
yeah, yeah.
exactly, yeah, yeah.
Yeah, it knows.
And I do also want to support more distributed, like. You have a parameter estimator, it's a separate tool, we want to use that one. Or, you know,
See, the point is in 10 years, the fuzzy may no longer exist, right? The front got run over in a bus, right? So.
No, Stefan will still be there.
And
Even if you get the.
which could still work when part of it exists,
Yes.
because there'll be some other tool that'll have implemented recognition of this.
Why did you run in the bus by any chance?
Well, somewhere.
So do you imagine there being like a higher level workflow orchestrator here or something?
Basically, yeah, I mean, it's like SEDML as it exists is sort of like a high level workflow
Yeah.
orchestrator.
Because I imagine like that could be something that's like configurable, right? Like it's like more of an
Yeah.
annotation that I want to run this, specific SAO ID as an operation using this tool. But if that tool is not available, you can substitute depending on your workflow.
Right,
Yeah,
I think
yeah.
that would make it more.
Remember, these tools will go away eventually.
So that's why we.
Well, that's the hope.
It'll rely
Behind
more and
Docker
more on the
containers.
second choice.
The hope of Docker containers is that if I need a particular simulator, I can pull up the Docker with that old thing and it's all.
That is the hope.
Yeah.
So.
In which case, it could be, I'm putting this.
I mean, I would say that at least extends your
It
timeline
could.
by at least
It could.
5 years,
It could.
maybe
Yeah,
longer.
it could, yeah.
I could see Docker containers living.
I mean, so like with biosimulators, for example, we're keeping archives of older versions of simulation
I know
tools.
theory.
And those are packaged images that will, run
Yeah.
exactly the same as they did before. Will
Right.
this last forever? No. I mean, there's going to be a paradigm shift probably at some point, but this is as future-proof, I think, as we can be right now.
Right, for those sorts of things.
All right, good.
All right, I'm gonna hit stop on this recording. Thank you all. And
The
it was good.
workflow, right? You specify specific.
Nice.
That's
Say it, so,
That they do that.